we are going to rely a lot in this lesson and in this chapter on using proportions. So first of all, we need to do a warm-up exercise, and we need to remember how to solve proportions. We cross multiply. So 10 times x is 10x, and 12 times 60 is 720. When I divide both sides by 10, I get x equals 72. Could you have done this by saying 10 times 6 is 60 to 12 times 6 is 72? You could have, but then you're actually using an equivalent ratios or really equivalent fractions number sense skill, and sometimes these numbers won't have that easy relationship, so you need to be able to solve them proportionally. Next one is a scale of a map. So once again, I'm going to use proportions, and I'm going to put 1 centimeter over 10 miles. I use the words as labels to help me understand that now this becomes 4.3 miles. So when I cross multiply, I get 10x equals 4.3. When I divide both sides by 10, I get x equals 0.43 centimeters. And the last warm-up exercise, a model train engine is 9 centimeters long. The actual engine is 18 meters long. So when they ask for the scale of the model, you can see that the relationship there is 1/2. Okay? Or they say 1 centimeters equals 2 meters. Corresponding angles are congruent, and the corresponding side lengths are proportional. So really what we're going to talk about is the same shape, but you can see smaller. So A, B, C, D, and E, F, G, H all have corresponding angles that are congruent. But AB, the ratio of AB to EF, is equal to the ratio of BC to FG, CD to GH, and AD or DA to HE. So let's use that information to actually solve some problems. List all pairs of congruent angles. They tell you that they're similar. So R is congruent to X. S is congruent to Y. T is congruent to Z. Now when they say check the ratios, that means that 25 over 15, okay, which I notice simplifies to 5 over 3, should be congruent to 20 over 12, which does simplify to 5 over 3, and 30 over 18. When it says write the ratios of the corresponding side lengths in a statement of proportionality. Well, I know that the corresponding side lengths are 5 to 3. So let's look at how they wanted this done. So we have the angles congruent. We have these, so when they say the ratios in part B, they said in a, check your wording, in statement of proportionality. So what they wanted was that RT over XY was equal to RS over, did that wrong. Clear that. RS, I'm looking at this first here, to XY. RS and XY is equal to ST over ZY, which is equal to RT over XZ. Okay. So let's try and see the practice questions here. If you're given triangle JKL, remember this symbol means similar. List all pairs of congruent angles. Write the ratios of the corresponding side lengths in a statement of proportionality. So that means angle J is going to be congruent to angle P. Angle K is going to be congruent to angle Q. Angle L is going to be congruent to angle R. And JK, PQ, that ratio is going to be equal to KL over QR, which is going to be equal to the ratio of JL to PR. Okay, and the last one I changed the order, but that works. So in this problem, they want to compare this to this. So the larger one to the smaller one. So 20 over 16. Those are both divisible by 4. So that's 5 over fourths. 15 over 12 is equivalent to 5 over 4. 30 over 24 is equivalent to 5 over 4. And 25 over 20 is equivalent to 5 over 4. So it is yes, the scale is 5/4. And for example 3, they want us to use this diagram to find the value. So I can see that 9/12, that's equivalent to 3/4. And 12/16 is equivalent to 3/4. So I need a number over 20 that'll be equal to 3/4. Well, 4 times 5 is 20, 3 times 5 is 15. I also could have cross multiplied and solved proportion and gotten that x was equal to 15. Here's the solution. And let's go over some more guided practice. The scale factor of QRST to ABCD. So smaller's on top, it's listed first, 6 over 12, 1/2. 4 over x I'm not sure about, but 8 over 16 is 1/2, 5 over 10 is 1/2. And find the value of x. Okay, this is the larger one, so 4 over x is equal to x being equal to 8. The ratio of lengths in similar polygons is the same as the scale factor. Theorem 6.1 shows that this is true for perimeters of polygons also. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. On a side note, they don't point this out here. This has to do with the fact that length of a side is one-dimensional and perimeter is one-dimensional also. So we can use that. Town is building a new swimming pool. An Olympic pool is rectangular with length of 50 meters and width of 25 meters. The new pool will be similar in shape, but only 40 meters long. Okay? So instead of 50 meters long, it's 40 meters long. That means the scale factor of the new pool, 40, to the Olympic pool, 50, is 4 to 5. The perimeter of the pool, of an Olympic pool, you can, as we said earlier, is 50 by 25. That's 50, that's 25. So the perimeter of the pool, of an Olympic pool, is 150. We're going to have the same scale factor. So when we cross multiply, we would get that x is equal to 120. Okay, we're going to actually now go ahead and use what we've just done to solve some problems. Find the scale factor of f, g, h, j, k. So that's the bigger one to the smaller one. All they've given us here is 10, but that's okay. 15 over 10, they're both divisible by 5, so that's 3 over 2. So the value of x, if it's 3 over 2, it's going to be equal to 18 over x. I can cross multiply, or I can see that 3 times 6 is 18, so 2 times 6 is 12. And they asked me to find the perimeter. So rather than finding all of, to clear some of my annotations there, it's 3 over 2. So when I add this up, it's 18 plus 15 plus 9 plus 12 plus 15 equals, and I can check in my calculator that I've done them all, 69. So 3x equals 69 times 2 is 138, divided by 3 is 46. Oh, I'd already pulled the answer away there. So the correct answer is 46. Any two figures that are congruent will also be similar in a 1-to-1 ratio. You know that perimeters of similar polygons are in the same ratio as the corresponding line lengths. You can extend this concept to other segments in polygons. If two polygons are similar, then the ratio of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygon. Let's talk about how we would apply this. In this diagram, find the length of the altitude PS. So everything corresponds. So if this is 6 to 8, and they go through this, 6 plus 6 is 12, 8 plus 8 is 16, so that's 3/4. So our new altitude is going to be 3/4 of 20, which would be 15. And we can go ahead and find it. So let's try this in a problem. You can freeze this if you want to. They want us to find the median of XM. Okay, so the median, remember, you have to remember your vocabulary from chapter 5, is the middle. So this is 48, this is 48, this is 40, this is 40. So 48 plus 48 is 96, and 40 over 40 is 80. So that ratio is going to be the same as 35 over what we want to find of Km. Okay, so that's 80x equals 35 times 96 equals 3,360 divided by 80 is 42. Okay, and that's how we would use the ideas that we've just learned to apply it to a So now we're going to see if you're ready. It's the daily homework quiz. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. Well, right away I can see that this to this is twice the amount. These are all twice the amount. So the scale factor is 2 over 1. So you can write this all out. Angle A is congruent to angle K, F is congruent to L, G is congruent to M, H is congruent to N. I believe you know how to do all of this. Okay, so there's your scale factor. Let's see if the similarity statements are on the next page or if they got cut out. They got cut out. You know how to do those. I'd be most concerned that you understand the scale factor. In the diagram, these two triangles are similar. They want you to find the value. So DE lines up with HJ. I always want to check these because sometimes in later sections they'll start rotating these figures around. So 12 to 8, they're both divisible by 4, so that's 3 over 2. So over here I have x for 9, 3 over 2. I have my larger one on top, my smaller one on the bottom. So 2x equals 27, x equals 13.5. So as you start to see, those start to get a little bit more confusing where you can't just use number sense to solve the problem. If two triangles have the scale factor of 5 to 4, find the ratio of their corresponding altitudes and median. It's all going to be the same. It's all going to be 5 to 4. If two triangles have the scale factor 3 to 7, find the ratio of their corresponding perimeters and areas. Okay, this is where we're going to get tricky. The scale factors of their perimeters is going to be 3 to 7. We didn't really cover this in the lesson. Area is two-dimensional, so you're going to take these numbers and square them. So you would have 9 and 49. So what do you think you would have if I asked for the volume, the ratio of their volume? That's right. You would have to cube everything. 3 cubed is 27, and 7 cubed is 343. You can also take some time and look at the problems from the textbook for homework. I hope you found this helpful.